Hello everyone. Today we are going to start with lecture number 2 of acid, bases and salts. So in the first lecture we studied about acids. What are the types of acids, the reaction of acids with various substances and all that jazz. Today we are going to study about bases, that what actually are bases and then the reaction of bases. So let's begin. What are bases? Now, bases are bitter in taste, they have soapy touch, they turn red litmus blue, and they give what? Hydroxide ion. That is what? OH negative ion in your aqueous solution. So, these are what your bases. Now, tell me a few examples for bases. Those are NaOH, that is your sodium hydroxide. Now, sodium hydroxide is also known as what? Your caustic soda. So, caustic soda. Also, your calcium hydroxide is another one, that is CaOH whole twice. That is what? Calcium hydroxide. You have one more, that is potassium hydroxide, that is what? KOH. Now, potassium hydroxide is called what? Your caustic potash. So, CaUSTIC, caustic potash. POTASH, potash. So, these are a few examples of your bases. So, let's revise it again. What are the properties of bases? They have a bitter taste, they have a soapy touch, they turn red litmus blue, they give hydroxide ions in your aqueous solution, and these are few examples for your bases. Now, tell me that what are types of bases? So there are two types, water soluble and water insoluble, right? So water soluble and water insoluble. So bases can be divided in two categories which are displayed on your screen, water soluble and water insoluble. Now the hydroxides of all the alkali and alkaline earth metals are what? They are soluble in water. So of alkali, that is AlKali, and alkaline earth metals, these are what? These are your water soluble. So these are what? These are your water soluble. And these are also known as what? Your alkali. Okay. For example, what? For example, your sodium hydroxide, that is NaOH. Then your magnesium hydroxide is also there. You also have your calcium hydroxide. So all these are what? These are the soluble ones which we were talking about. Okay. Now alkali is basically considered as what? Your strong bases. So these are considered as what? Your strong bases. Like we were having strong acids, similarly we have strong bases, and like we were having weak acids, similarly we also have a concept called what? Your weak bases. Okay, so now let's move forward and let's see the reactions of bases. So in reaction of bases, the first one is reaction with metals. So tell me one thing, when your bases are going to react with metals, what are they going to do? Like your alkali are going to react with your metals. They are going to form what? They are going to form salt and hydrogen. Okay. Now we know how to check this hydrogen. In the previous lecture, we studied that we have to bring what? A burning candle, and this gas is going to burn with a what? A pop sound. So we know how to actually check the contents of hydrogen, not exactly the content, but whether the gas which is evolved is hydrogen or not. We also know about your CO2, that is carbon dioxide gas, correct? So this is the reaction which is going to take place when your bases are going to react with what? Your metals. So whenever the alkali is going to react with the metals, we will form what? We will form salt and hydrogen. And what are going to be the examples? The examples are like your sodium hydroxide reacting with zinc to form what? Your sodium zincate and hydrogen gas. Then again your sodium hydroxide reaction with your aluminium and water is going to give what? Sodium aluminate and your hydrogen. So these are few examples of reaction of base with metals. The next one is reaction with oxides of non-metals. Right? So we need to what? We need to react your bases with oxides of non-metals. So what's going to happen when my base is going to react with oxide of non-metals? So oxide of non-metals. So what is actually going to happen when this reaction takes place? Basically your salt and water is this substance, are these substances which I'll get. So I'll get salt and I'll get water. So like see, here in these reaction you can see water and water on the product side, and these are the salts. This one, I'm so sorry, and this one. Okay, so sodium carbonate and calcium carbonate, these are the salts which are formed when the reaction happen, and this is your water molecules. Okay, so the examples are going to be what? Pretty simple. Sodium hydroxide, when reacts with carbon dioxide, is going to form what? Your sodium carbonate and water. When your calcium hydroxide is going to react with carbon dioxide, then it's going to form what? Your calcium carbonate and water. So these are the examples when your bases are reacting with what? Oxides of nonmetals. Okay, pretty simple. So in the previous case, in the first case was reaction of your bases with metals. In that case, what was happening? That your alkali plus metals were reacting and they were forming your salt plus hydrogen. In this case, your base and your oxides or of non-metals are reacting and they are forming what? Your salt and water. Correct? Yes. So now moving forward, the next reaction is basically what? Your neutralization reaction. So in your neutralization reaction, what happens is whenever an acid plus a base is going to react, they are going to form salt and water. Okay, and this simple reaction is termed as what? Your neutralization reaction. Because an acid neutralizes a base when they react with each other, and what are formed? Salt and water. The respective salt and respective salt of your acids and bases are going to form, and water is also going to form. Now what are the examples? The examples is like HCl reacting with NaOH. So whenever HCl reacts with NaOH, Na and chlorine are going to form your NaCl, that is your salt, plus OH and H are going to form what? Your water. And this is exactly what is shown here, that whenever the hydrochloric acid and sodium hydroxide are going to react, what is going to form? Your sodium chloride and water. So these are the substances which I'm going to get. Correct. Second is when my hydrochloric acid is going to react with calcium hydroxide, what's going to form? Calcium chloride, which is nothing but a salt, and water. So these are the two reactions which you need to keep in mind. There are so many more reactions, but these are sufficient for you to understand that how the reaction is going on. So this is what? This was your neutralization reaction. If we move forward, the next reaction is going to be what? The next reaction is going to be reaction of acid and metal oxides. Correct. So whenever I talk about metal oxides, so metal oxides are what? They are basic in nature. So they are basic in nature. So metal oxides are what? They are basic in nature. So now what we are talking about? We are talking about acid and base. Correct? Because your metal oxide is what? It's basic in nature, and we have the reaction of metal oxides with what? Acids. So whenever my acid and metal oxide is going to react, what is going to form? Come on. Salt and water. Simple. Just in the previous slide, we studied about the neutralization reaction, and in that case, we said that whenever acid and base reacts, they form what? They form salt and water. And now we are studying about metal oxides reacting with acid. And I know that metal oxide is what? It's basic in nature. So whenever a base and an acid is going to react, what's going to happen? Come on. Base and acid reacting, it's going to form what? Your water plus your respective salt. And this is the example which is given, that is hydrochloric acid, which is your acid, and calcium oxide, which is nothing but your base. They react to form what? Calcium chloride, which is nothing but your salt, and water, that is H2. Correct. So acid plus base reacting to form respective salt and water. So this is exactly what happens when there is reaction of metal oxides with your acid. Correct. Correct. So next is what is common in all the bases. So common in all bases. What is common in all bases? Like there was this one thing which was common in all acids, and that one thing was the H positive ion which is liberated, which it liberates. Okay. So what is common in bases? If H positive is in acids, in bases we have what? Hydroxide ion. Simple. So basically what happens? Whenever a base is in aqueous form, it's going to dissociate into what? Ions. and one of the ion is going to be what? Your hydroxide. Like for example, if I talk about sodium hydroxide, then it's going to dissociate in what? It's going to dissociate in your sodium ion, that is Na positive, and OH negative, that is my hydroxide ion. Similarly, if I talk about potassium hydroxide, that is KOH, it's going to form what? It's going to form K positive, that is my potassium ion. See here, this is potassium ion in aqueous solution, means in aqueous solution it's dissociating. And then OH negative, aqueous means it's in aqueous form. So this is what? This is my hydroxide. So this is exactly what is common to all the bases, that whenever it's in aqueous form, it's going to dissociate and give me what? OH negative, that is my hydroxide ion. So this is exactly what is common to all the bases. So hydroxide ion in bases, this is common to all the bases. Like your H positive was common to all your acids, right? So it's pretty simple. Once we have understood acids, we know that okay, these are the reactions which we need to learn, and on top of that we are adding what? Bases. That okay, this is the reaction which we did in acids, so how the base is going to react with that particular substance. This is what we studied in acids, so how a base is going to react in that situation. So it's just similar. That's why I started with acids, because it was like easier to understand, and now we can fast say complete off with bases because it's easy for us. Okay, moving forward, now we are going to understand a little bit about what is neutralization reaction. Okay, reactions are done for the bases, but now we are going to study a little bit more topics. Now, neutralization reaction. So let's study what that is. So whenever an acid reacts with the base, the hydrogen ion of the acid combines with the hydroxide ion of the base to form what? Water. Correct. As these ions combine together and form water instead of remaining free, thus both of them does what? They neutralize each other. So what I'm trying to say is that hydroxide ion came from what? A base, and my hydrogen ion came from what? An acid. Alright, so whenever a base is going to react with an acid, the hydroxide ion in the base and the hydrogen in the acid, they are going to react with one another and they are going to neutralize one another to form what? Water. As they are cancelling out each other to form a neutral substance, that is water, instead of remaining free as ions in the solution, therefore the reaction which occurs is known as what? My neutralization reaction. Okay. Now when sodium hydroxide, which is a base, okay, so sodium hydroxide, which is what? Which is a base, it reacts with hydrochloric acid. Then sodium hydroxide, this basically dissociates in what? Na positive and OH negative, correct? And this dissociates in what? H positive and Cl negative. So obviously OH and H are going to do what? They are going to react to form what? Water. So what I'm basically saying is, I'm saying that whenever sodium hydroxide is going to react with hydrochloric acid, sodium hydroxide is going to dissociate in your Na positive and OH negative. And your hydrochloric acid, that is HCl, it's going to dissociate in what? In your H positive and Cl negative. So H positive and OH negative which are present here, they are going to form what? Water. And Na positive and Cl negative which are present here, like here and here, they are going to react and form what? NaCl. So at the end I will get what? Your sodium chloride, that is nothing but my salt, and H2O, that is nothing but water. Okay, so this is exactly what the reaction is. It's pretty simple neutralization reaction. It's just that when acid and a base is reacting, it's going to form salt and water. And you just need to check it out. Like acid, we were talking about NaOH, and base, we were talking about HCl. So hydrogen ion and hydroxide ion, they are going to form water. What is left? Cl is left and Na is left. So NaCl, that is sodium chloride salt, is basically what is formed. And this is the respective salt for what? Your acid, that is your acid, that is your HCl. So this is your acid, and your base, that is NaOH. This is wrong. So your acid is HCl and your base, that is what? NaOH. Correct? So water is going to form, and the respective salt is what? NaCl, that is going to be formulated. So the next thing which we are going to study about the dissolution of acids and bases. So what is the meaning of dissolution of acids and bases? Now I know That acid give me what? Acid give me H positive, whereas base give me what? Base give me OH negative. Correct. This thing we understood. So let's read this and understand that what is the meaning of dissolution of acids and bases. Okay. Now the concentration of hydrogen ion in an acid and hydroxide ion in a base per unit volume shows the concentration of acid and base. This is pretty simple to understand, that whatever the concentration of hydrogen ion, that is H positive ion, in your acids is going to be there, and whatever concentration of OH negative, that is my hydroxide ion, in base is going to be there per unit volume. This shows me the concentration of what? Acid and base. Obviously, if they are going to be more H positive, that means the acid is more concentrated. Okay. And similarly, if they are going to be more OH negative ion, this means what? This means the base is more concentrated. Correct. Simple. And if there are lesser number of H positive ion, this means my acid is diluted. Whereas if there are lesser number of OH negative ions, this means that what? My base is diluted. Okay. Now let's move further. By mixing acid to water. So I am mixing what? Acid and water. Okay. The concentration of hydrogen ions per unit volume decreases. This is simple because initially I only had what? I had acid, so there were this, H positive ions which were there. But when water came, then the volume increased. Correct? Because initially, suppose this is my container and this is the amount of acid which is present there. Okay, this red one which I filled with color, this is the amount of acid which is present in my container. Okay. Now, when I'm going to add water, suppose I added itna pani. ठीक है, itna pani I added and it all mixed. So now this contains what? This contains acid plus water. So the volume increased. The volume increased. But the concentration of H positive ions decreased per unit volume. Correct? Correct. And similarly, if I'm going to do the same thing with a base, then obviously if I'm going to add water to a base, then the concentration of OH negative ions is going to decrease. So the concentration of my OH negative ions is definitely going to decrease when this happens. Okay, let me just erase this. I'm sorry. Okay, let's just not erase this. Let's just cross this. So the concentration of OH negative ions is going to decrease. Correct. So similarly, it's saying what? It's saying that similarly by addition of base to water, the concentration of hydroxide ion per unit volume is going to what? It's going to decrease. Now this process of addition of acid or base to water is called dilution, and acid or base is called diluted. Okay, that means whenever I'm going to add water to either my acid or base, then dilution is going to happen. Dilution. Okay, because I am making my acid or base more diluted. Alright, but when I'm going to add acid or base to my acid or base, suppose I add acid to acid, suppose there was H2SO4 and I added more H2SO4. So it's forming more concentrated. And suppose there was NaOH and I'm adding more NaOH to it. So I'm doing what? I'm actually increasing the concentration because वो और concentrate हो रहा है, because there is more amount of what? Suppose I had NaOH and water. So this is a solution that I'm having. Okay, this is a solution that I'm having. Now I added water to it. So what is going to happen? The concentration of water is increasing, but the concentration of NaOH, or you can say OH negative ions, is same. The concentration of OH negative ions is same, but the concentration, or you can say the amount of water is actually increasing. So when the amount of water is increasing, but the amount of OH negative ions which is present is the same, can I say that the concentration of OH negative is decreasing per unit volume? Absolutely. But if instead of water, I am adding NaOH again into this solution, so what is going to happen? That the concentration of OH is actually increasing per unit volume. So the concentration, because the concentration of OH negative is increasing per unit volume, can I say that this solution, which initially composed of NaOH and water, after addition of more NaOH, the concentration of OH negative actually increased? Correct, I can say that. So in this case, I can say that it's more diluted. When I'm adding a base to a mixture of this, or suppose instead of NaOH, it was HCl plus water, and I added more HCl to it. So I can say that I am actually making it more diluted because I'm adding acid to acid or base to base. Correct. But instead of HCl, if I added water in this, so I was doing what? I was reducing the concentration of H positive ions per unit volume that was initially present when the mixture of HCl and H2O was there. In that case, I could say what? I could say that I was making it more dilution. Okay, I was making it more what? When I am adding more water to HCl or H2O, then I am doing what? I am doing the process which is called your dilution. Okay, so this is the difference between your dilution or diluted. I hope you understood. It's not easy, it's pretty simple. But what it's saying is that whenever I'm adding water to my acid or base, then the process which is happening is your dilution. And when I'm adding acid or base to acid or base, then the process which is happening is what you're diluted. All right, so let's read further. Now it's saying that the dilution of acid or base is exothermic. Exothermic means release of heat. So exothermic basically means release of heat. And what is endothermic? Entry of heat. Just remember, exo means exit, exit. So exothermic means release of heat, that there is exit of heat. Whereas when I say endothermic, okay, whenever I say endothermic, endo means entry, N means entry. So that means we require heat for the reaction to happen. Now what it's saying is that the dilution of acid or base is exothermic, which means that whenever I'm adding water to acid or base, then heat is liberated. Alright, thus acid or base is always added to water and water is never added to acid or base. Why? Because if I have acid, like a lot of acid, and if I'm going to add water to it, then a lot of heat is going to be generated. Okay, and then it can cause some sort of damage or explosion or anything. Okay, but if I have water and I'm adding little by little, drop by drop of acid or base, then the heat which is liberated is going to be absorbed by the water. All right, so the chances of your explosion or damage or a large amount of effervescence or anything is reduced. Correct? So if water is added to concentrated acid or base, a lot of heat is generated which may cause splashing out of acid or base and may cause severe damages, as concentrated acid and base are highly corrosive. And this is exactly what I taught you right now. It's pretty simple. Okay, so this was the topic of dilution of acids and bases. I hope you understood that what is the difference between your dilution and diluted, and I hope you understood that whether we add acid or base to water or water to acid or base. All right, so do not make mistakes while you are doing any kind of experiments in your school, because this is important. Okay, it will save you from any damage or anything. It will just save you. Be safe. The next topic which we are going to study about is strength of your acid and base. So what exactly is strength of my acid and base when I refer to this? Now the thing is that this topic of strength of acid and base is somewhat related to pH, not somewhat, but yes, it's related to pH and indicators and all that. And this topic we are going to touch in the next lecture. But today let's just understand a little bit of what is strength of acids and bases, and then in the next lecture we are going to study this in a more elaborated form. All right, now acids in which complete dissociation of hydrogen ion takes place, they are called your what? Strong acids. Obviously, whenever I have an acid and complete dissociation of hydrogen ion takes place, those are my strong acids. We studied in the last lecture, right? What are strong and what are weak acids. And similarly, on those aspects itself, bases in which complete dissociation of hydroxide ion takes place, they are termed as what? My strong bases. So we have strong bases and strong acids, and we have weak bases and weak acids. All right. So what they're trying to say is this is your pH scale or something, but let's just forget that there is anything called pH. So basically what they're trying to say is that this mark is the neutral mark. This is neutral mark, okay, where water is there. If I'm going to increase the concentration of H positive ions, so you can see that here I have more H positive, then the H positive ions are decreasing. Okay, when I'm going towards my right hand side, the concentration of H positive is decreasing. This means that the highest concentration of H positive is on the left hand side. So here my strong acids are going to be there. Here my strong acids are going to be there. Whereas on this side, my weak acids are going to be there. But when from the neutral point, I go towards my right hand side, you can see that further H positive concentration is decreasing, but the concentration of OH, here it should be OH negative, OH negative is increasing. Okay, H positive is decreasing, but OH negative is increasing, and here the OH negative is maximum. So it means here I have what? My strong base. Whereas because here the concentration of OH is what? Limited. So I have my weak bases, and this is what? This is the neutral point. So when from neutral point I am going to go in this direction, then the concentration of H positive is increasing, whereas the concentration of OH is decreasing. That means whenever from the neutral point I am going towards my left hand side, then I am approaching the strong acids. But from the neutral point when I am going towards my right hand side, then the concentration of H positive is decreasing, whereas the concentration of OH negative is increasing, which means that when from the neutral point I am going towards the right hand side, then I'm approaching what? Strong bases, whereas when I'm going towards the your left hand side, then I'm approaching what? My weak bases. So this is what is referred to as your pH scale. It is this, but we are going to study about the pH scale in next lecture. I hope you understood it now. All right. Now in mineral acids such as what? My hydrochloric acid, sulfuric acid and nitric acid, etc., hydrogens ion dissociate completely, and hence they are considered as strong acids. And since in inorganic acids, hydrogen ions do not dissociate completely, so they are weak acids. So this is nothing but they are referred to as what are strong and what are weak acids. And we already know that what are strong and what are weak acids, and we know what are strong bases and weak bases. So this was basically what was the strength of acid and bases. It's related to this scale which is termed as your pH scale, and pH scale is also, used for what? Your indicator or anything. So we'll see, we'll understand that in next lecture. But before going, let me tell you one thing. The pH for your water, or your any neutral solution is going to be what? 7, whereas the pH for your acids is going to be less than 7, and your pH for your bases is going to be what? Greater than 7. So pH for water is going to be 7, pH for acids is going to be less than 7, whereas pH for bases is going to be greater than 7. So this point, let me change the color so as to show you more clearly, because I feel it's a lot of blue there. Alright, so here, this point, this is my neutral point, and this is nothing but 7 pH. If I go towards the right hand side, then that is greater than 7, so bases are going to come, and the strongest base has pH of 14, you can see. Whereas when from this neutral point I'm going towards the left hand side, then I'm approaching 0. That means strong acids have approximately 0 pH. Okay, 0, 1, this is like extremely strong 0 and 1. So when I'm approaching towards this, I'm approaching what? Strong acids. That means the acidic nature is increasing and basic nature is decreasing. And when I go from here to here, then the basic nature is increasing, whereas my acidic nature is decreasing. So we came to the end of the lecture. Let's recap what all we did, and then we can just relax and do some tests related to it. Okay. So we studied about bases, that what are the bases, properties of bases, then types of bases, whether they are water soluble or water insoluble. Then we studied about the chemical properties of bases, that is the reaction of a base with a metal, then reaction of base with oxides of non-metals, And lastly, about the neutralization reaction and reaction of acids with metal oxides. Then we studied that what's common in all the bases, that is OH negative ion. We studied about the neutralization reaction again. We studied that what is the dilution of acids and bases, and lastly, what are strength of acid and bases. So I hope you people understood whatever I taught you today. Now, what you can do in the meantime, before you actually go and check out lecture number 3, you can go to EduRev site and you can just attempt some tests and see some documents on acid bases and just read them and bring the topic into your head in such a manner that you never forget it. It's a very, very simple and very interesting topic. So go ahead to EduRev's website and study. All the best.